You, you need to give me permission to share screen.
Okay, you should be able to share screen.
Yep. Are you hooked up by HDMI? Yes. Well, I was gonna try and hook up the sound, but probably there's not gonna be a lot of background noise. Um, Are you ready? Yes. Paul, can you tell whether there are people on the Zoom?
Yeah, there are 15 people
Okay.
on the Zoom.
Okay. So I guess I need to stand close enough here. People can, yeah. Well, welcome everyone in person and online. This is, my name is Steve Bertman. I'm currently the chair of the Climate Change Working Group. I want to welcome you to another event of Climate Emergency Month, and remind you that there are a bunch of upcoming events that you can find on our website, and the address I was hoping could be in the chat, but I guess maybe not. For students, we have a QR code for Experience WMU to scan in and announce your attendance at this event, and there are prizes that you can win at the end of Climate Emergency Month. Hopefully we'll be able to put the URL in somewhere online, so that you can, if you're attending remotely, that you can log your attendance. So I'm going to put this QR code in the back of the room, and if you want to scan it in, please do. So it's a great honor and privilege for me to introduce Dr. David Karowe, who is a very good friend and colleague of mine. We've worked together closely for a long time. Dave did his bachelor's work at Harvard University and earned his PhD in chemical ecology at that other Michigan school down the road in Ann Arbor. After a few years at Virginia Commonwealth University, he joined the faculty in the Biological Sciences Department at Western in 1996. His field of research in chemical ecology deals with how food webs are affected by elevated CO2 caused by increasing CO2 concentrations from the burning of fossil fuels. And if you want to hear a great story and see some really gruesome pictures, you should talk to him about that research. Probably for the last 10 or 15 years, Dave has become the region's expert on climate science and the ecological impacts of climate change. Probably certainly the campus expert, probably more requested as a speaker in the region than anyone else on campus. And so it's an honor and a treat for us to have him here. And I'll get off the stage now, and hopefully all the technology will work. And the QR code will be in the back of the room. Take it away, Dave.
Thank you, Steve. Thanks very much. Yeah, Steve and I have known each other for a long time in a variety of contexts. On the racquetball court as each other's primary opponent. We decided long ago that in the interest of collaboration and partnership, we would not keep score. So that's been when we're healthy, that's been a great, and we've run
Dave's concession to my inferior play.
Steve just made a self-deprecating comment. We won't repeat it because it isn't true. So when I volunteered to give this talk, my thinking was, okay, Kalamazoo declared a climate emergency. The city of Kalamazoo did, the university, Western Michigan University did as well. But it may not be clear to people why there's a climate emergency locally. I mean, clearly there are major problems happening around the world and much bigger ones in store if we continue along our current emissions pathway. But it may not be clear to people what is the emergency in my own backyard, or is there even one? So I thought I would put together a talk that tried to use the literature as much as possible to answer the question, why is there a climate emergency for Kalamazoo? And disclaimer right off the bat, there isn't any published study that focused on Kalamazoo and the climate effects on Kalamazoo. So the projections that I'll be talking about, showing and talking about today are inferred from studies that looked at a larger scale. Could be Great Lakes region, could be global. But those larger scales included Kalamazoo. And so what I'll try to do is highlight what their prediction was for the local environment. Okay, so we should probably start off just asking what's been happening. How has climate been changing in Kalamazoo? A lot of the talk today will focus on temperature, the temperature component of climate change. Climate change includes global warming and any other changes in climate. We'll focus on the global warming component mostly. So when we ask how has climate been changing, first thing we want to ask is about temperature. How's temperature been changing in our region? Statewide, we've warmed about as much as the planet on average, and that's about 1 degree Celsius since 1895 or so. You might have expected that given our proximity to large bodies of water, that we would have warmed less. Right? Large bodies of water have thermal inertia, and they tend to make temperature swings on land nearby smaller. But despite having large bodies of water on basically all sides of the state, except the south, we have warmed at about the same rate as the average for the entire planet. And like the rest of the planet, the rate of warming has been increasing for us. It's about, for Michigan as a whole, it's about 3 times faster since 1975. So that's also been happening for the entire planet, that warming is accelerating. As a consequence of this regional warming, the surface water of the Great Lakes has also been warming. NOAA has a number of buoys out on the lakes. Every place that has color in this map is a part of the surface area of the Great Lakes that had statistically significant warming during the 20 or so year period indicated in the legend 1994 to 2013. There would be larger areas with color today. And I'd like to point out that there are parts of Lake Superior that are warming at an alarming rate. Oops, sorry, I'll back up. This area, darker red area of Lake Superior, the surface water has been warming at a rate that would equal 50 degrees Fahrenheit by the end of the century. It won't continue warming at that rate, but that makes it an entirely different ecosystem for anything that lives, certainly in the surface water. And the vast majority of those things have very limited abilities to move to a lake that would be more suitable. So Lake Superior is changing the fastest. Lake Michigan is also increasing in temperature. And one of the things that has been documented in Lake Michigan, this is a little bit maybe of a complicated slide. Just look at the top row first. That's surface water, 0 meters, 0 to 1 meter deep. And in pretty much all months, except for some reason August, there's been statistically significant warming. That's also true in some of the months down to over 100 meters deep. So it's not just the surface of the Great Lakes that are being impacted. The deeper waters are too, which of course means that the things that live in deeper waters are experiencing some of the same changes, probably stresses, that surface organisms are. One of the consequences of warming water is it's harder for ice to form. And ice cover has decreased quite dramatically by 71% since 1973. And the scale on the left, the colors indicate the number of days per year lost, of ice cover lost. So the number of fewer days per year where ice is actually on the lakes. And if we focus in on the part of Lake Michigan that's most relevant to Kalamazoo, that part of Lake Michigan has been losing ice at somewhere between half and 1 day per year, the rate of half to 1 day per year, which over this 40-year period means 20 to 40 days fewer of ice cover. And that has a lot of consequences for communities, ecological or human communities that are downwind of the lake, because that allows more lake effect precipitation. It allows more time for water to evaporate from the lakes and therefore allows greater lake effect precipitation, which we have been getting in increasing amounts. And this year is a great example. If we look at ice cover in 2023 for Lake Michigan, the blue line here is the average from 1973 to 2022. The red is this year. And except for a little blip early on, we have been well below average ice cover for Lake Michigan. The other Great Lakes have also been much lower than normal. One thing I would like to point out, it'll show up on a future slide also, is I don't know if you guys can see my cursor. No. Okay, so the onset, sorry guys, the onset of ice cover in 2023 was two to 3 weeks later than normal. The red line doesn't come up off of zero for quite a while. And that has consequences especially for deep water fish. And we'll talk about that why in a little bit. The bottom, I'll give you cut to the chase. The bottom line is that oxygen gets mixed down into the deep waters when the ice leaves in the spring. That is a time of spring mixing, and oxygen gets mixed down into the depth, and then it stops. And oxygen doesn't get replenished in the deep waters until ice basically starts to form, a little bit before ice forms in the winter. So the fact that the ice formation is later means that whatever oxygen mixed down in the spring has to last now 2.5, 3 weeks longer than it used to have to last. And it's already by that part of the year getting to be stressfully low oxygen levels for deep water fish like trout, salmon. Okay, one of the other consequences, as I mentioned, of reduced ice cover is greater lake effect snow. If you are on the downwind side of any of the Great Lakes, this is Buffalo about to get pummeled by really an extreme or severe precipitation event that's in the form of snow, in the form of lake effect snow. And we all know what happened to Buffalo this year. Lake effect snow is likely to increase for us, for Buffalo, for Rochester, for Syracuse, for at least 20 years. And then once the air temperature warms to the point where the water doesn't freeze into snow and comes down as rain, we'll get lake effect rain instead of lake effect snow. Okay. Overall, in terms of precipitation, what's happened in Michigan and Kalamazoo area is pretty much what's happened in north temperate areas across the globe, which is a moderate, slight to moderate increase in average annual precipitation. For our part of the world, for our backyard, it's a 5 to 15% increase in precipitation over the entire year. But that doesn't really tell us much about how precipitation is changing. What we want to know is, has it been a gentle increase, as in very slight increases throughout the entire year? Has it been an increase in the time when we need rain the most, in the summer, or has the increase been mostly in the winter? And has it been in the form of gentle rain events or extreme rain events? And the answer is most of the increase has been in the form of extreme precipitation events. In our region, these kinds of rain events that send water down to the ground much faster than the ground can absorb it, and therefore the water pools in low points, we call that flooding. Those kinds of events have increased by 42% since around 1960. And that's an average for the entire Midwest region. It's also the documented rate of increase for Grand Rapids. Grand Rapids has had about a 46% increase. I assume Kalamazoo has as well. As a consequence, Kalamazoo's had a lot of flooding recently. We have had, at last count, 3 rain events that were so intense that they used to happen once in a century. So we've had 3 once-in-a-century rain events in the last decade. And each one has caused significant flooding. The top 2 images are from 2018, severe precipitation. You may remember in 2019, our football stadium, Waldo Stadium, flooded, and the homecoming game had to be delayed because, well, football gear doesn't include scuba equipment. So, and then in 2021, we had another round of flooding. And this is all without dams breaking or anything else. This is simply because of extreme precipitation events. Okay, so we've been experiencing climate change, no question. We can, later on, I will actually speculate about what consequences that has had for ecological systems in our region and to some extent for human health. Okay, but mostly, if there are studies that focus on nearby cities, it's either Chicago or Detroit or once in a while Grand Rapids. So like I said, there won't be any, almost no information that's directly about Kalamazoo. There is a little bit, but most of it will be inferred from studies that include big cities nearby. When we ask what kind of future climate change will Kalamazoo experience, the only answer that is reasonable at this point is we don't know. It depends on what we decide to do about greenhouse gas emissions. So Kalamazoo's future climate change depends on our choices about greenhouse gas emissions. And I would like to put 3 of the choices that are most discussed in the context of historical atmospheric levels of carbon dioxide. From going 400,000 years into the past, based on air bubbles that are trapped in Antarctic and to some extent Greenland ice cores, it's very clear that carbon dioxide fluctuated between about 180, about 280 parts per million in our atmosphere, coinciding with temperature cycles, but it never got above 300 parts per million until about 1950. We started to really burn fossil fuels seriously about a century before that, industrial revolution, let's say 1850. The current level here, this is a slide that's now about 7 years old. The current level is 20 parts per million higher than indicated on this. It's about 418 parts per million averaged over the whole year. Okay, so what are the emissions choices that are often discussed? The one that's our default at this point is what I call business as usual. That name is sometimes applied to other emission scenarios, but business as usual is continuing along our current path. And that current path gets us to 950 parts per million by 2100. And as a consequence, causes Earth to warm on average about 5 degrees Celsius. Another option that's frequently discussed is the Paris Agreement option, where most countries, almost every country on the planet, agreed to voluntary emissions reductions. Not enough to keep warming to 2 degrees, but the Paris Agreement itself has that as its first goal. And that would require that we stabilize atmospheric CO2 levels at about 550 parts per million. And as a consequence, cause Earth to warm roughly 2 degrees Celsius above pre-industrial temperatures. A better option, and one that we're still hoping will become the target, is what but nobody else that I know of calls Paris Extended. So if you ask someone about the Paris Extended emission scenario, they will not have a clue what you're talking about. It's generally referred to as the 1.5 degree scenario, but we'll refer to it as Paris Extended during this talk. It requires that we, by the end of the century at least, get atmospheric CO2 levels stabilized at 450 parts per million. Some of those emission scenarios include overshooting 450 and coming back down. That would require carbon removal technologies that we don't have yet, but may develop and so on. So, but it's still a reasonable, a possible target, or one that we could possibly achieve. And like I said, it would result in warming ending at about 1.5 degrees Celsius above pre-industrial. Okay, what will we have to do to make any of those three, or actually the two better ones, come to actually be the true future for planet Earth? We don't have to do anything to have the business as usual future become reality. That's the path we're headed on. Judging by not the commitments that countries have made, but the cuts they have made. So I'm not going to show that what we would have to do. We would not have to cut emissions from what we're planning at this point. But if we want to limit climate change to 1.5 degrees or even 2 degrees, we have to start dramatically reducing greenhouse gas emissions now. That's why we're in a climate emergency. An emergency means you don't have time to waste. You've got to act now. And we are in that position, hence climate emergency. This is the emissions pathway we would have to follow if we wanted to have not 100%, but at least a 2/3 chance, 67% chance of keeping warming below or equal to 1.5 degrees by end of century. And those are very steep emissions cuts. The y-axis is global annual net emissions of carbon dioxide. So it's emissions minus whatever carbon dioxide is drawn out of the atmosphere by the ocean, not by the ocean, by plants, by photosynthesis and so on. There is no emission scenario that makes us 100% sure we will keep warming below 1.5 degrees. There are enough uncertainties in the climate system, including many positive feedbacks, that may mean we've already committed Earth to over 1.5 degrees warming, but we don't know that. So we'll assume that it is still a possible target and we can put a probability on it, but very dramatic emissions cuts would be necessary to give us a 2/3 chance of keeping warming to 1.5 degrees. If we said, okay, we're happy to have a 50% chance, then still very steep emissions cuts, not quite as dramatic. In the first case, we need to become carbon neutral as a planet by 2040. To have a 50% chance, we need to become carbon neutral as a planet by 2055. If we wanted to have a 67% chance of keeping warming not to 1.5 degrees, but to 2 degrees, we need to become carbon neutral by about 2065, 2070. All three require dramatic emissions reductions that have to start now. If we delay 10 years, we have basically a 0 chance of reaching the 1.5 degree target. So hence a climate emergency. How would those two futures differ? Well, we're heading towards a very unpleasant future. That'll be the one on the right, we'll call business as usual future. But we can still change course. And we could aim instead for what we'll call the Paris extended 1.5 degree future. One of the things about changing course for climate has tremendous inertia. So I think of it as the only thing that I picture as requiring a really long time to change direction, which is one of these massive cargo ocean liners that if they want to go to a different port, they have to start turning when they're still very far out to sea. If we want to head towards that 1.5 degree or even 2 degree port, we've got to start turning that wheel as fast as we can, as quickly as we can. Okay, so how would those two futures compare? What we'll see is having a hard time getting the. Okay, so the year is in a black square at the bottom. The business as usual future, the one we're heading towards on the right, temperature scale is at the bottom, and the Paris extended future is on the left. By 2050, there's already quite a dramatic difference between the two, but the real differences arise during the second half of the century. The planet on the right by end of century 2096 is a planet that is in many ways uninhabitable. Certainly for the human population that we have now. It's not a planet that could support 7 billion people. I don't know how many it could support, but it's a planet that would have massive agricultural failures, massive water shortages, almost certainly very pronounced and probably continual armed conflict over what are now essential but very limited resources. Okay, that's the future on the right. But we could head to the future on the left. What would this mean for Kalamazoo? All of those things I mentioned are reasons that Kalamazoo is also in a climate emergency. If India and Pakistan engage in a nuclear war over water from the Indus River, without which Pakistan can't survive, but which flows through northern India before it gets to Pakistan, when that flow decreases to the point where there's not enough for India, and it doesn't let any go to Pakistan, and Pakistan has nuclear weapons, Kalamazoo is going to be affected by an armed conflict, especially a nuclear conflict there or anywhere. So it really is part of our climate emergency. Okay, so let's look into the future and ask, well, if we follow different emission scenarios, what will happen to future temperatures in the Kalamazoo region? Here's a prediction, actually, I think probably one of the most well modeled predictions about summer temperatures in the Kalamazoo region. And if you look at the bottom left-hand corner, of course, Southwest Michigan, under business as usual, the image shown here, the summer temperatures in our region would increase by about 7 degrees Celsius. That's more than the global average. The global average is about 5 degrees. Under the Paris Agreement, this is just 2 degrees, not 1.5. 2 degrees was what was modeled in this study. The Kalamazoo region would experience increased summer temperatures of about 3.5 degrees. So it cuts the warming about in half. So instead of 7 degrees, we're at about 3.5. I'll show a little bit later that under the higher warming scenario, there's also a big decrease in precipitation. Under the 2-degree warming scenario, there's a decrease, but nowhere near as big. If I were a farmer, there's absolutely no question which future scenario, which future I would prefer. Actually, if I were pretty much any living thing in the region. Here's summer precipitation. Under business as usual, in the Kalamazoo area, the prediction is about a 7% decrease in summer precipitation. It's bigger decreases elsewhere in the region. Under the Paris Agreement, it's essentially no decrease, maybe a 2-degree decrease. So if you have a large increase in temperature and a reasonable increase, 7% is a lot of decrease in precipitation. That, of course, would be much more stressful. Conversely, the Paris Agreement future would be much less stressful for species, ecosystems, and of course, for humans as well. So we talked about average annual temperature. We talked about average summer temperature. What about extremes? Those are going to matter more to living things than averages. And one of the measures of extreme temperature in the future is an entire summer that is hotter than what is currently the record hot summer for Kalamazoo. Okay, and the prediction under business as usual on the left and under Paris Agreement on the right are quite different. By 2070, under business as usual, the prediction is that the probability that Kalamazoo will have, that a Kalamazoo summer will be hotter than our current record hot summer is 90 to 100%. So by end of century, virtually all summers will be unprecedentedly hot in Kalamazoo. Under Paris Agreement, it's in that light green region, somewhere between 10 and 50%. These new record hot summers would occur, but nowhere near as frequently. If we ask another measure of extreme heat, temperatures, days above 100 degrees Fahrenheit, and here is a prediction that's specifically for Kalamazoo. Currently, on an average year, we have 0 days over 100 degrees. By 2050, under business as usual, we're predicted to have 9 days per year over 100. By 2075, 14 days, and by end of century, basically a full month of days over 100 degrees. Not necessarily consecutively, but a lot of them would be consecutive. Would that change under a Paris Agreement future? Actually, yes. It cuts down the number of days over 100 degrees fairly, not much by 2050. Most of the emission scenarios produce about the same temperature change by mid-century, but later in the century, we see the benefits of the Paris Agreement, reducing the number of days over 100 degrees by 1/3 to 1/2. And Paris Extended would do even better. Basically, we'd have an increase in number of days over 100 till mid-century, and then a very slight increase for the second half of the century. Temperature itself is not really the best measure for human impacts on human health. What's a better measure is called the heat index, which includes temperature and humidity. A 100-degree day is a lot more challenging for a human body if the body can't evaporate water, can't sweat and have the sweat evaporate because the air is too humid. So relative humidity is a big part of the health impacts of hot days, and the heat index includes both of those. So for instance, if a day is 90 degrees hot, but it has 75% relative humidity, it would feel pretty oppressive to us and would act like it would be a day that had a heat index of 109. A heat index above 90 makes it dangerous to work outside, especially if you have any pre-existing conditions. A heat index above 100 means that children and elderly adults have a decent chance of being hospitalized or dying if they spend too much time outside. And a heat index above 105 means pretty much everybody runs a decent risk of hospitalization and or death if you spend too much time outside. Heat index off the charts, which I'll show in the next slide, is something that's never happened. So the National Weather Service doesn't have any calculations for that, a heat index that extreme. Okay, so let's ask, well, given that heat index is a better predictor of human health impacts than temperature alone, what are the predictions about heat indices of various levels for Kalamazoo County in the future? And it turns out the bottom line is the same as it'll be for almost everything. Rapid emissions reductions, acting like we really are in an emergency, would substantially reduce the number of what are really dangerously hot, dangerous heat index days. So historically, Kalamazoo County has had 15 days with a heat index, this is not temperature, this is heat index above 90, 2 days above 100 degrees. We haven't had days over 100 degrees Fahrenheit, but we've had days where relative humidity makes it feel like it's over 100 degrees, never over 105. And the off the charts or no analog is over 127 degrees heat index, which of course would be very, very challenging for anyone spending any amount of time outside. First, let's look at the predictions for 2050 for our county under business as usual, under Paris Agreement, and then the number of days prevented by the Paris Agreement relative to business as usual. Number of days per year under business as usual with a heat index above 90 jumps from 15 to 55, over 100 from 2 to 22, over 105 from 0 to 10. Still no, by mid-century, no days with a heat index over 127. Paris Agreement is lower. Remember, by mid-century, they aren't that much different in their effects on climate, but still reduce 10 fewer days with a heat index over 90, so 10 fewer days, 9 fewer days, heat index over 100, and 5 fewer days with a heat index over 105. What about end of century? By end of century, under business as usual, the prediction is we'll basically have close to 3 months of days with a heat index over 90. Remember, that's a day that's dangerous to spend a lot of time outside. If you like gardening, that's going to be a problem. Even more of a problem are the 46 days over 100 and 30 over 105. And for the first time ever, Kalamazoo would experience days with a heat index over 127. Paris Agreement would reduce those. In fact, the Paris Agreement produces about the same increase or about the same number by end of century as it does by mid-century. That's a consequence of stabilizing CO2 levels in mid-century. And so the number of dangerously hot days prevented by the Paris Agreement by end of the century is really quite remarkable, including all of those days that would be off the charts. Okay, so that's the number of really hot days over the entire year. Of course, they'd occur during the summer, most of them, but from the point of view of human health, what matters is not only the heat on a given day, but how many consecutive days have dangerously hot temperatures. In other words, how often and how extreme will heat waves become? We can ask that or get a handle on it by asking, Okay, how many consecutive days over 100 degrees predicted for Kalamazoo, the Kalamazoo region? Historically, we've had less than, so that color indicates 0.1 days per year up to 10 days per year. It's a 2 order of magnitude range. It's not very helpful, but we know already we've had less than 1 day per year. So of course we've had less than 1 consecutive day per year. Under business as usual, the prediction is that for our corner of the world, Kalamazoo County would experience about 20 consecutive days over 100 degrees. We've never had that. Kalamazoo is not equipped to deal with that. There would have to be major adaptation measures put into place. Things like community air conditioning buildings, something like that, splash parks. So of course, the better option is just not letting that happen by reducing emissions. Under Paris Agreement, we'd have about 3 days per year, consecutive days per year, over 100 degrees. So still a problem, but nowhere near as big a problem. And by limiting warming to 2 degrees, we would prevent about 6 heat waves per decade, a little more than half the heat wave per year. And very importantly, those that occurred would be shorter. They'd be about 3 days shorter. Why does that matter? Because mortality increases exponentially as the heat wave goes on. The really deadly days are the later days. If you don't let them happen, you obviously reduce heat wave mortality in this case, pretty dramatically. If we ask, well, how many Kalamazoo people would die in these heat waves? Again, no study has looked at, for instance, heat-related mortality in Bronson and Borges hospitals as a function of temperature, but those records do exist for large cities, including closest one to us, Chicago. Chicago had a heat wave in 1995 that killed almost 800 people. Yeah, it was a very mild heat wave by future standards, but still, and yeah. So for Chicago, under current conditions of, the distribution of air conditioning and so on, Paris Agreement is predicted to prevent about 450 heat-related deaths per year by mid-century and about 3,700 heat-related deaths per year by end of century. When we talk about the cost of reducing emissions, of shifting away from fossil fuels, you always have to compare it to the cost of not doing that. And this is one of the costs of not doing that, or another way to look at it is a benefit. Hard to put in financial terms, but clearly a benefit of rapidly reducing our emissions. If we adjust for the Kalamazoo population, it's about 75,000, and the same mortality rate happened, that would mean that Paris Agreement would prevent about 10 deaths per year by mid-century and about 100 deaths per year in Kalamazoo by end of century, heat-related deaths. And nationally for our entire country, the prediction is the Paris Agreement would prevent about 35,000 heat-related deaths per year by end of century. Heat waves would be dramatically reduced in Kalamazoo by rapid emissions reductions. And we can ask, well, what's the probability that Kalamazoo would experience not just any old heat wave, but a heat wave that's worse than the worst heat wave known in human history, which was the 2020 Siberian heat wave pictured here. Okay, what's the probability that Kalamazoo would have a heat wave worse than that? And the annual probability is given by this scale. It's hard to see, of course, Kalamazoo in these maps, but I'll highlight it for you in writing. For Kalamazoo by 2021, under business as usual, the probability is about 50% in any given year. These would be a frequent occurrence for Kalamazoo. Under the Paris Agreement, I don't know if you can see the arrow pointing to where I think Kalamazoo is. It's a little hard to get. I mean, PowerPoint doesn't let you have such great control, but anyway, that you can see that the probability is basically zero. We'll call it less than 1%. And under Paris extended also less than 1%. So basically, rapid emissions reductions would remove a 50% probability in any given year by end of century of having a heat wave that's worse than any that humans have ever experienced so far. Okay, what about droughts? If you get heat and lower precipitation, of course, droughts, which is also the most lethal extreme event for land-based life forms, including crops. The prediction is not even under business as usual, but under 3-degree warming, not 5 degrees, 3 degrees. Our region would experience a 300 to 500% increase. It's basically orange and red in the area where that arrow points to. So under 3-degree warming, droughts would be 300 to 500% more severe under Paris Agreement, and under Paris Extended. Paris Agreement, it's a little hard to interpolate. So somewhere between no increase and maybe a doubling of drought severity. And under Paris Extended, pretty clearly no increase in drought severity predicted. Again, if I were a farmer, or pretty much anything living on land in our region, that would be important. That would be a major reason to lobby for rapid, dramatic emissions reductions. One other consequence for human health would be that if we are going to meet these, if we're going to dramatically reduce emissions, we're going to have to stop burning coal. There's no question about that. We need to, I mean, it's a horrible fuel. It's our absolute worst choice, in my opinion. In part because it puts a lot of CO2 into the atmosphere, but it also puts a lot of things, particulate matter that gets into our lungs and throughout our body and causes damage to our pretty much all of our organs. And as Dr. Berman would be able to describe in more detail, some of the stuff that comes out of coal-fired power plant smokestacks catalyzes the formation of ground level ozone, which basically burns anything it comes in contact with, including human lung tissue. Okay, as a consequence, Michigan currently experiences about 1,100 heart attacks and about 700 deaths per year due to the fact that we are downwind from coal-fired power plants. And that estimate is remarkably similar by 3 different studies that independently came to that. Okay, on this map, the yellow are coal-fired power plants. The red indicates mortality per 100,000 people. And each county has its own mortality rate. If we look at, so first of all, if we rapidly reduce emissions to meet 2 degree or 1.5 degree, we'd get rid of all of these coal-fired power plants as quickly as possible. I think it's an absolute mistake to wait until they sort of senesce on their own. Absolutely not. They're killing us. Get rid of them now. Replace them with non-dangerous electricity sources, solar, wind, and so on. Okay, so all of that mortality, all of that red would disappear. And if we look at inside that little circle, Kalamazoo County, our mortality rate is such that they reduce, eliminating coal-fired power plants would prevent 7 deaths per year in Kalamazoo County. Okay. One thing that we don't think about as necessarily being a bad thing, unless you are the owner of a ski resort in Michigan, is the winter's going to warm too. And so we'll have less days below freezing. And in fact, under business as usual, the prediction is a pretty dramatic decrease, 50 fewer days per year below freezing. Again, that may sound like a good thing unless your livelihood depends on snow, or your livelihood depends on days below freezing because your fruit crops need those days in order to flower in the spring. They need a chilling period. So under business as usual for our region, it's about 50 days fewer. And that can have an impact on the ability of cherry, apple, even blueberry to flower. And if they don't flower, they don't produce fruits. 50 fewer days conservatively means 500 fewer hours below freezing. And right now, Kalamazoo has maybe 1,400 hours per year below freezing. There are not, to my knowledge, cherry varieties that can reproduce with 900 hours of chill period. So maybe others will be developed or imported, but this should be a real concern for Michigan fruit growers. So maybe we can't grow those crops. But under a Paris Agreement, instead of 50, it's 20 fewer days. And most likely we would still be able to produce large crops of fruits. One other danger to not just fruit trees, but we'll talk about fruit trees first, but also other Michigan plants, is a phenomenon called a false spring. We probably just were through one. A false spring, they can be very damaging, and they occur when you have abnormally warm temperatures. January was really warm in Michigan. Okay? And it fools plants into thinking it's spring. They aren't fooled by 2 days or maybe 5 days of much warmer than average temperatures, but almost everything is fooled by 10 days. And so they start to develop. They start to act like it's spring, and so they start to develop leaves and flowers, and those are delicate tissues. And they develop to the point where there's no turning back and there's no starting over. They're at a very vulnerable phase, and then a frost happens. Winter comes back. So it wasn't a real spring, it was a false spring. And on the left is a cherry tree with snow on it. On the right are damaged cherry flowers that will never produce fruit. Okay. We don't know what the frequency change has been in Kalamazoo, but in Illinois, essentially same latitude, false springs are now 7 times more common than they were in 1970. And false springs are not bad only for plants. They're bad for pretty much everything that uses temperature to start being active in the spring. And among the things that do are virtually all insects in Michigan, in Kalamazoo County, all the butterflies, all of the bees, all the pollinators. They can be killed quite easily by false springs. The reason is they enter diapause, which is their version of hibernation. So in the fall, day length shrinks to a certain point, that's the critical photoperiod, and they stop feeding, they become inactive, and they pump their bodies full of antifreeze. And then they just stay that way until they think it's spring. And temperatures increase, they break diapause. And if all is well, their plants will be starting to put out the nice, fresh, young leaves as well. But if it's a false spring, they break diapause, they come out at a time when day length is increasing in the spring. So they can't go back into their version of hibernation. What do? They die. Yeah. How much has this been happening in Kalamazoo already? We don't know. Almost certainly it has been happening. We have noticed a large-scale decrease in insect populations. People notice butterflies before others. Pollinators have their own issues. The insecticides or herbicides they're used. But in addition, they all have this false spring issue that I think is already having a huge impact on, think of every beneficial insect in Kalamazoo County. There's another component of climate change that I think presents a new challenge to insects, and that is that autumn leaf fall, we see it as leaf fall is happening later. Autumn is happening later. But what sends insects into diapause is a particular day length. That's not changing. That's still happening at the same time as it always happened. But it's now followed by a longer period of warm days. And an insect stores up energy and other resources, basically as fat, during the summer. And that fat is what they live off while they're in diapause. So if you're going into diapause, but it's still warm for quite a while, and you're cold-blooded, your respiration rate is higher because the temperature is higher. Your respiration rate, the rate at which you use up your fat reserves, is greater because it's warmer longer into the fall. So if there are higher fall temperatures, that can cause them to use up their stored fat reserves faster and basically starve before they can start to feed again in the spring. Is that happening? Probably. But nobody is measuring either of these ways in which climate change is affecting Kalamazoo insects. But I think it's clear that rapid emissions reductions would benefit Kalamazoo insects. And in doing so, everything that relies on them. Think bats and birds, right? So one thing before we get to things that rely on insects is an iconic species that doesn't go into diapause here. It migrates. It's one of the very, very few Michigan insects that gets out of here during the cold period. That's the monarch butterfly. But it also would benefit from rapid emissions reductions, even though it's not experiencing these diapause-related effects. The predictions for changes in the Kalamazoo population by 2100 under business as usual is an 80% decrease. Okay, that's a really unsustainable decrease. Paris Agreement, 20% decrease. Not great, but monarchs, we might not even notice a 20% decrease. Things that rely on insects include, among others, birds. Audubon Society has put a lot of effort into predicting the fate of different bird species under different levels of climate warming. It's based entirely on physical components of the environment, temperature, precipitation, so on. It's not based on insect availability. So everything we just talked about would make it even more challenging for at least insectivorous birds. But what they predict is basically gives us the same conclusion. Rapid emissions reductions would be great for Kalamazoo birds. It would prevent most of them from becoming what's called highly vulnerable, which is basically on the verge of local extinction. Here we see the prediction for 3-degree warming, not business as usual, less than business as usual. And the prediction is that 13 species, the ones are shown here, would become highly vulnerable basically in Kalamazoo, in our zip code. The predictions are made for each zip code. Another 34 would become moderately vulnerable. Under 2 degrees, if we limit warming to 2 degrees, it's only 5 species that become highly vulnerable and 6 fewer species moderately vulnerable. If we meet Paris extended, it's only 2 species that become highly vulnerable. So basically the Kalamazoo bird community stays the same, or at least we don't lose a lot of species. One thing I'll just point out for our freshwater aquatic ecosystems is they'll both be affected. Lakes by warming and summer stratification period being longer, oxygen suffocation at depth. In moving waters, rivers, streams, and so on, the warming will have an effect, but a big effect will be changing rates of flow, changing flow regimes. We'll have more high flow days, mainly in winter and spring. And anytime there's a severe precipitation event, we'll have more low flow days when it's hotter summers with less precipitation. So high flow days, winter and spring, the prediction under business as usual is for Kalamazoo region, 86% increase in high flow days. They're not great. They can dislodge things and push them downstream. Paris Agreement, it would still be an increase, but less so, still 55%. The big difference is in change in low flow days, which are the worst. Low flow days, the water gets very hot, it's shallow, and if it's hotter, it can't hold as much oxygen. So it becomes stressful in many ways. Under business as usual, about a 50% increase predicted in low flow days, but under Paris Agreement, basically no change, 3%. And if I were a member of Trout Unlimited, this would be enough to get me to lobby very hard for dramatic, rapid reductions in emissions. Okay, how do we get there? How can we what can we do to help prevent warming from exceeding 1.5 or at least exceeding 2 degrees? And the most important part of the answer is we've got the tools we need. We can change the future by using tools that are already available. One is, and I think this is our most important tool, quite honestly, for achieving the overall result, we've got to make climate change our major voting issue. As important as other things are, every social justice issue will be dramatically worsened by climate change. There's absolutely no question about that in my mind. So voting based on a candidate's stance on reducing climate change is voting in favor of more equity, more justice in the world in all kinds of ways. Okay, so the people who are in those buildings, more than anyone else on the planet, except maybe in China, control the fate of Earth. And that means that we have to be extremely diligent about getting people into policymaking decisions who will make the policy that is in the interest of the humans. And to do that, basically you become a climate voter. Just make it your #1 priority. That's certainly it is for me. But you accomplish a whole lot of other social justice goals by electing people who will minimize climate change. Another important thing is whoever is in office, tell them they need to support, they need to finance, they need to incentivize low carbon energy sources. Why can we get rid of coal? Because we have much better ways to generate electricity. We can get rid of natural gas for the same reason. What are some of the better ways? These are to some extent in the Inflation Reduction Act. I mean, the Earth made a major gain. The future of our planet changed dramatically when in the 2016 presidential election, in an absolutely horrible way, the future of the Earth became much bleaker. We will have a hard time recovering from it, but the 2020 election was a major change in a good direction. So what do we need to tell them? We want more wind, we want more solar. And we want at least 80% of our electricity to come from smarter energy sources, saner energy sources by 2040. And we want to move things that are currently running on fossil fuels to running on electricity instead. For instance, transportation. We want electric cars, not oil cars. Okay, what is the potential for these? Could they really do it? Any of 3 existing solar technologies could provide right now 100 times all of the energy that humans use in all forms globally. Michigan, we could provide, we would have to use photovoltaics, but we could provide about 10 times all the electricity that Michigan uses if we wanted to ramp up solar farms. Wind energy has at least the potential to at least provide at least 40 times all of the energy that humans use. And again, and that's in all forms. So we shift as many things to electricity. We electrify as much as possible, improve the grid, people may think of these as just impossible challenges. And whenever I hear that, I say, well, you realize that this is a country that more than 50 years ago figured out how to put humans into a little metal box, blast them off of the surface of our planet, land them gently on the moon to go around, prance around and plant a flag, and then get back in that box and blast off from the moon and return safely while burning through the atmosphere of Earth to be reunited with their families and live out a long and happy, fulfilled life. That was 50 years ago. We figured that out. We can figure out better wires and better batteries. Okay, so third thing we can do is lower our personal, mainly our household, carbon footprint. A typical household, the carbon footprint is dominated by two things, really. Mobility and food, with housing, which is mainly heating, a close third. So what can we do? We can, next time you buy a car, buy an electric car. There is an incentive, $7,500 for new models in general, for buying electric. Buy it even if it costs more. The return on investment is worth it. So Chevy Volt, buy a plug-in hybrid or buy an all-electric. They now have ranges of 300 miles on a full battery charge. Eat lower on the food chain. Eat a low carbon diet. Food is about 30% of a typical household carbon footprint, and turn down the heat, turn down the thermostat in the winter, turn it up in the summer. Basically turn it in the direction you don't want to turn it in. Okay. Don't cool as much in the summer, don't heat as much in the winter. It's remarkable how quickly humans acclimate to different temperatures. So those are all things we can do, and they'll have immediate impacts. Okay, it's basically using less fossil fuels while we don't have a choice. And of course, electrifying requires that we change our sources of electricity from coal and natural gas to wind and solar. Really important thing is talk about it. It's been made a political issue so that you don't talk about it. You're worried about getting into an argument with somebody. 70% of Americans think climate change is happening. And what is it, Steve? Close to 60% think humans are responsible. That means there's quite a bit better than 50-50 chance that a random person you struck up a conversation with would see at least the important things the way you do, and be open to the conversation. There are a few who would be very resistant, but even they are gradually changing. So we've got to talk about it. The easiest people to talk about it are people that you feel pretty sure think like you do with your friends. Good, by all means. Branching out a little bit, maybe people that you encounter daily at in the work environment, you may not know how they think. You don't have to engage in an argument. You can simply plant a climate fact on their radar. Hey, did you know that almost 100% of the experts say that humans are the primary cause of climate change? I didn't know it was anywhere near that high. Even if you did, say, I didn't know that. And then just walk away. That's a very powerful fact. The experts agree. And it is a major source of disinformation. So just put it on someone's radar and walk away. I do that with bank tellers all the time. Okay. Talk to people who you think don't agree with you. Talk to people who think differently. If they are dead set in denying climate science, don't waste your time, is my suggestion. But if they're open, if they listen, you're not wasting your time. Engage them, even though it may take a while for them to admit the science. And especially talk with young people, because the future of the world is basically in the hands of young people at this point. People in my generation, we've tried, some of us have tried very hard, but we are not convincing the rest of humanity to stop stealing your future. That's what we're doing. Okay, we're living a life of convenience on fossil fuels, knowing full well it comes at your expense. Don't let us do that. A number of us don't want to do it, don't want our generations to do it, but we need your voice also. Two voices that are missing, that are very powerful if they get engaged: youth voice and the faith community's voice. It is an absolute ethical issue, the biggest one we're facing. So you can also join what I call Climate Truth Organization. If you are 30 or below, you are encouraged to join the Sunrise Movement. That is the youth climate movement internationally. Here is a picture of Sunrise activists sitting in Nancy Pelosi's office. It doesn't have to be, you don't have to target just people who are climate deniers. People who understand climate science and accept it aren't acting as quickly as they need to. They aren't acting as if it's an emergency. Sunrise Movement, man, it gets a lot of press. And if it gets a lot of press and there are a lot of boots on the ground, you have a much better chance of causing positive action. Another wonderful group is called Citizens Climate Lobby. It basically is lobbying for a carbon fee and dividend, where carbon is taxed as it enters the economy. That tax is returned, it's a fee, it's returned to all Americans as a monthly dividend check. Almost certainly the first kind of climate legislation will really have. And as I intimated, getting involved in public action is, I think, absolutely necessary. It is clearly past the time for demonstrating in public our concern and our concern about the lack of urgency in what is clearly a climate emergency. So get involved, or maybe even organize public actions. One of the current focuses, Bill McKibben and 350 and others, is banks that make large loans to fossil fuel companies, particularly oil companies, so that they can afford to go explore and drill and find more oil. And if banks had a policy of not lending for undertakings that would increase use of fossil fuels, then that would decrease the use of fossil fuels in the future. So if you want to, for instance, go and hold a sign in front of Chase Bank, downtown Kalamazoo, March 21st, a week from today, is the day for an ideally coordinated global action to encourage banks to stop funding new fossil fuel ventures. Okay, bottom line, if we want to limit warming to 1.5 or 2 degrees, we need to reduce dramatically, very quickly, greenhouse gas emissions. We have to start now. And that is the reason that, along with the rest of the planet, Kalamazoo is in clearly a climate emergency. And we have the tools to start changing the future. We need to start using them. It's no longer good enough to say we have the tools. Someone else should start using them. No, everybody needs to put pressure on policymakers to start using them, and in our own lives do what we can. Those are two very different futures. Okay, if you're 20 years old today, you will probably live to 2096. And these are two planets that you could have available to, two of many possible futures, but two that are strikingly different. So bottom line is, we need to start acting now. We can, we have the tools, we need to start using them, and that will let us be some of the people who save the world, because that's really what it amounts to. Okay, thank you very much for your attention here and on Zoom. Be happy, of course, to answer any questions that anybody has. Can you see the Q&A on the webinar? I'm trying. Yeah, normally I can see it. Sorry, Steve. So chat, yeah. There we go. I can see the chat, but I don't see anything in it. Oh, Q&A, sorry. Okay, so Q&A. Hi, Don. I'm glad you were able to use the updated link. So do the figures discussed today include the temperature increase expected when cooling due to pollution from fossil fuels is removed? Great question, Don. So humans have been changing the atmosphere mostly in ways that warm Earth, putting more greenhouse gases in. But we've also been putting in little teeny particles, generically called aerosols, that most of which have the effect of cooling Earth because they bounce sunlight back to space before it can hit Earth's surface and get turned into heat. And all of the predictions that I talked about do include decreasing aerosols. Of course, under the business as usual scenario, coal continues to be burned at a not much reduced. It reduces a little, but not much. And so that masking effect of aerosols is part of that prediction. Warming would be greater if the burning of coal if the particulates were removed at the smokestack. Warming would be even greater. By the way, one of the things that's sort of interesting to me, for the same emissions, CO2 emissions and other greenhouse gas emissions, models are now predicting greater warming than they did 10 years ago. Exactly the same emissions, greater warming as predicted. Why? Because parts of the climate system that were not well understood 10 years ago, which included feedbacks in the climate system. Warming causes this change. That change accelerates warming. That's a positive feedback. They weren't well understood, and so they were left out of the models and not used in predictions. As research has quantified those feedbacks, and as models of computers have gotten more powerful, models have been able to include feedbacks, most of which are positive, and that results in the same emissions now having a bigger effect. And so, yeah, the predictions do include aerosols, and they include some, but not all of the climate feedbacks, most of which are positive. Hi, Tim. So thank you for your regrets about Citizens Climate Lobby not being able to be here. I hope you feel better soon. Okay, so I see one from Nikki. The ocean is absorbing both heat and carbon dioxide. What's the limit before the ocean is exhausted? It's a great question, Nikki. I don't think it'll ever become exhausted because there is transport. The absorption happens in the surface, and there is transport of both heat and carbon, although not as carbon dioxide, into depths. But one thing that is a very important part of your question is that any liquid can hold less gas as it warms. So warmer water holds less CO2 than colder water. As the ocean warms, its capacity to pull CO2 out of the atmosphere decreases. Okay, now the CO2 in the surface, some of it is incorporated into calcium carbonate shells, basically of phytoplankton, things like foraminifera. And when those phytoplankton die, their shells and the carbon that they contain sink to the bottom. They eventually formed things like the White Cliffs of Dover, limestone. Okay, so the carbon that's absorbed from the atmosphere some of it is moved into the deep ocean. And I think that will prevent the surface waters from ever becoming fully saturated. But even before they're fully saturated, and I think this may be one of the things you're also thinking about, Nikki, that carbon dioxide that's absorbed eventually causes more carbonic acid in the surface water. So the oceans are acidifying. And that's a problem for anything, including the forams, including corals, including bivalves that use calcium carbonate to make their shells or their substrates. So ocean acidification, unfortunately, is a massive challenge for marine organisms, especially coastal ones, especially ones involved in coral reefs. The heat, I think also there's no limit to what the ocean can absorb. It's already absorbed about 93% of the heat that humans have trapped.
Follow up on that. Have people study the impact of acidification of the Great Lakes?
Right. So Steve asked, has there been any work studying the extent of and consequences of acidification of freshwater lakes, including the Great Lakes, and in particular the Great Lakes? As far as I know, there has not been. And one of the reasons that the Great Lakes are relatively immune to acidification is that much of the bedrock, as you know, Steve, underlying the Great Lakes is limestone. And so the Great Lakes actually are pretty well buffered against acidification, unlike Adirondack lakes or Northeast lakes where the bedrock is granite and cannot neutralize acid that's either falling as acid rain or getting converted or getting made out of carbon dioxide that's absorbed. So as far as I know, I don't know of any study that's looked at the extent of or the consequences of Great Lakes acidification. And I suspect that that's in part because they're less vulnerable than most lakes because of the underlying bedrock. They are warming faster than almost all other lakes on the planet. And that's because we're in the zone, kind of mid-temperate zone, where historically the lakes have been covered by ice for a good part of the year. But as you've seen, that ice cover is disappearing. And so the surface that used to reflect a whole bunch of sunlight back to space is now gone. And instead the open water is being hit by the sunlight, and open water heats up. It changes sunlight and visible wavelengths into heat. So we have a sort of mini positive feedback happening in what have historically been seasonally ice-covered lakes. And we're right in the latitudinal zone where that feedback is fastest, and so our lakes are warming quite fast. One of the things that, in expanding a little on Nikki's question, one of the challenges we have is, and I think this is a place where a lot of research investment should occur. And that is, we need to develop ways of pulling carbon dioxide out of the air where it is not especially concentrated. It's 4/100ths of 1% of normal air. If we can pull carbon dioxide out, we can't rely on plants. They won't do it enough. But if we could somehow pull carbon dioxide out of ambient air, then that would be a game changer. So we should really invest in carbon dioxide removal, free air carbon dioxide removal, in my opinion. But one thing to keep in mind is that all of that heat and all of that carbon dioxide that's been absorbed by the ocean when we start taking heat out of the surface and carbon dioxide out of the atmosphere, that just means that heat and CO2 are going to move from the ocean into the atmosphere. The ocean will purge. So we need to continue removing both heat by reducing greenhouse gas emissions, possibly other ways, and removing carbon dioxide. We will need to continue doing that for a long time. If we get a way to do it, for a reasonable price, and I think a reasonable price is still, I think a very expensive is still a reasonable price, because the alternative is immensely expensive. Yeah, that we need to do that. It would be a game changer, but it's not going to solve things immediately. It's a long-term solution that would have immediate effects, but we'd have to continue doing it for long term. Okay. And I just want to make sure that I'm seeing all or taking these in order. Sorry. So Deirdre, hi. So I'd mentioned that getting involved in public action is a good thing. It's a good thing to mention. It's a good thing to do. Can I suggest ways that students can engage in research that would help inform, for instance, the modelers that are making predictions. I assume that's what you're talking about, Deirdre. And one way, because you've done it, and that is, it's a program that no longer exists. Last year was the final year, but Steve and I for 30 years, Steve for 10 years, have run a research training program, climate change research training program for undergraduates. We've trained over 300 undergrads to do climate change research, some of which has produced results that have made models more accurate, that have been used to update models. So that's one way. The other way, Deirdre, really is get involved, and probably easier to do as a grad student than an undergrad. Get involved in a thesis or a dissertation that allows you to do research that looks at a cause or a consequence of climate change. In the audience here, one of my graduate students, Joe Figursky, is a prime example of that. He's spent last summer trying to figure out how a particular type of forest disturbance that will become more common under climate change impacts local amphibian communities. Okay, something nobody has asked before. So there are ways. Generally, you want to get attached to somebody who's doing some kind of research that you're interested to. Easier to do as a grad student, but you can still do it as an undergrad. The best thing is look for research experience for undergraduates, RU programs. There are hundreds of them nationwide. All have a theme. Ours was not the only one that focused on climate change. Sorry, I think I skipped over one. So Jonathan asked, are there specific government actions you can recommend that should be taken? What things would you put into a state law or a list of regulatory actions if I could write it? Man, that's a dream come true question. It's like, yeah, exactly. It's a wonderful position to fantasize about being in. I could put into action things that would actually help. What I would do is immediately have a plan for phasing out coal-fired power plants and replacing the electricity they generate with wind and solar within 5 years. We could do it, no question. We don't want to do it. We may say it's too expensive or it's too inconvenient, or we don't have the grid that would allow dispersion of that electricity efficiently enough. Hey, moonshot 50 years ago. We have better wires, and we can figure out even better ones. So I would, among the policies would be more investment in research into how to make even better versions of the low carbon electricity and other energy technologies that we have, but also implementation. And I would require all utility companies to phase out coal generated electricity. Again, I would say within 5 years, but 10 years maximum. And provide funding for ramping up, especially wind and solar, possibly also geothermal. So, I mean, what is our defense budget for this year, in this year's budget? $818 billion. Okay. Would we be substantially less safe if it was $800 billion? And $18 billion this year we put towards preventing climate change. 18 billion could go a long ways. And of course we could dedicate much more than that. Money is never an issue. It's wanting to spend the money that's an issue. So I would immediately target electricity generation. I would also require that all vehicles sold in the United States were fully electric by 2035. I mean, the bottom line is we're leaving the rate of change to the people who don't want change, who benefit. They're among the very, very few people on Earth who substantially benefit from continued use of fossil fuels. And they are either setting policy themselves or getting people elected who will set policy in their favor. So, I would use the immense financial resources of the federal government to make things happen that absolutely have to happen. So thanks for the question. And I would do it at the federal level, anything that would be done at the state level, or even regional level would be great. Michigan is, we're now on the forefront of climate change action because of our governor and to some extent, our Attorney General and Secretary of State, and now both houses of our legislature, of our Congress. Okay, so Nikki said you can't hear me. Okay, so Nikki had a question. Not sure what the question was about. Won't heat affect the animal fish life? Yes, everywhere. In freshwater, in marine systems for sure. And she said that she just read that Lake Victoria is evaporating. Will that happen to the Great Lakes? Actually, it's one of the predictions that has become less certain. There's a weaker consensus about what will happen long term to Great Lakes water levels. And it's clear that there will be more evaporation from the lakes. Severe precipitation events tend to have more of the water from that kind of rain event end up in the lakes because it doesn't have to go through the ground. It just runs across the surface. It brings other junk with it. So severe precipitation events probably will lead to higher lake levels. Water thermal expansion will lead to slightly higher lake levels. And a huge impact is what will happen to the amount of water that doesn't end up in the lakes, in the Great Lakes, because trees pull it in through their roots and respire it through their leaves. And that the change in what's called evapotranspiration is hard to predict. It is affected by temperature, for sure. Greater evapotranspiration at higher temperatures, that means more water exiting through trees, less going into the lakes. But on the other hand, higher CO2 levels make plants shut their stomates, the holes through which water evaporates, sooner. So higher CO2 leads to less evapotranspiration. And I would say the jury's still out on what the long-term prospects are for Great Lakes water levels. There's probably about a 2/3 consensus that they will decrease by maybe a meter or even two by the end of the century. But there is a substantial number of quite valid studies that predict no decrease or even an increase. So I think the jury's still out on that. I think that is the last question I see in the Q&A. Anybody in the room? Yes.
But I'm wondering from a local or a regional perspective, are there emerging systems or emerging movements that can help us deal with the fact that the fossil fuel companies are looking more and more to plastics and proliferating plastic products and that's such a hard thing locally to deal with as well, all the single-use plastic bags,
Right.
for instance.
Right.
And so just whatever direction you want to take that issue of plastics, fossil fuels.
Right.
And then kind of local, regional,
Right.
creative problem solving.
So Lynn asked, basically, what about plastics and how is it related? Maybe how is it related to climate change? And what can we do about the fact that fossil fuel companies, especially oil companies, are interested more and more in using petroleum to make plastics? And those plastics, they, on the one hand, so this is what I would say, on the one hand, they're long-term carbon sequestration. On the other hand, they're a horrible method of long-term carbon sequestration. One of the huge things that we can do about climate change is just consume less, reuse more, recycle more. We are just such a consumer-oriented society. It's amazing to me how often we replace useful things with other things that are no more useful, but they're just newer. So anyway, plastics, as Lynn said, are notorious for being single-use. Bring single-use plastic bags. I would phase them out. I would make them illegal. Maybe give people easy access to reusable grocery bags. Or I would restrict the plastic bag use to certain places where they're really much better than alternatives. I think it's crazy that we buy bottled water at a price that's higher than gasoline at the pump. And then throw the bottle away. I haven't thought about it much, how to reduce that problem, but the one good side is it takes carbon out of the ecosystems, out of the carbon cycle for almost ever. But everything else about them are horrible. Do you have suggestions?
I wanted to see where you went with that.
Yeah.
Carbon sequestration is not where I thought you were going to go with that.
Oh, no. Yeah, no, it's not part of the reason for them at all. It's just an inadvertent consequence. Yeah. So I think, the mentality of buy, consume, discard is one that has to change. It's a cultural, it's a part of our culture that is incompatible with a livable future in many ways, including in terms of climate livability. Okay, well, thank you all here and remotely for your attention. I'm, of course, more than happy to answer any questions. Afterwards, my email is easy to find. My last name, Karowe at westernmichigan.edu. And so I know Don was planning to send some questions my way. I'm more than happy to answer any that anybody has. Thank you again for your attention.